Hi, my name is Yogesh Prabhu, and today in this video I'm going to teach you how to find out DFT, discrete Fourier transform of a function that is given to you. So I've taken one example here. Supposing if the question says find discrete Fourier transform of x of n and x of n is given to you as 1, 2, 3, 4, it is a discrete signal. Now, how do you find DFT? Well, to find DFT, there are at least 4 to 5 different methods. Okay, so we will go through that one by one. First, we will solve with the most principal method. Now, I just want to make one point very clear that DFT is an amazing transform. It has got a lot of applications in various engineering fields and everything. So, but then in this video, I am not discussing about the applications of DFT. So this is going to be strictly about the procedure, that if you have a question and if you're asked to find out DFT, how you can solve and how many ways you can solve. There are at least 4 or 5 methods that you can solve this particular question, okay, to find DFT. So we get started. So let's just talk about the first method. First method is actually the lengthiest method, but then this is like the real method. Supposing if in exam they ask you this question for like say 4 marks, then you should be solving using the method 1. And then there are some shortcut ways of solving as well. We will cover that eventually. And then there is fast Fourier transform. All that is coming up. So let me like number my methods. The first method, the longest but the most authentic method. I'm going to use the formula of discrete Fourier transform to find out DFT of x of n. See how it goes. The first, let me write down method 1. And method 1 is by Dfp Formula. Now here I'll be using Dfp Formula itself to find out DFT of x of n. Well, let's start solving. Solution by Dfp Formula. You have to remember the formula for discrete Fourier transform. When you find discrete Fourier transform, you get xk. Now observe how I write the capital X and square bracket k. That's just a notation that we follow. And then this is equal to summation of n is equal to 0 to n minus 1, that's not infinity, x of n w n raised to nk. Well, this is the DFT formula, and wn raised to nk is called as the twiddle factor of discrete Fourier transform. We'll talk about that in detail when we are talking about the significance of Fourier transform and what it does and capabilities and properties. All that is the topic of the another video. As of now, it's just the focus on how do we solve if you get a question like this. Now, well, here for this x of n, the capital N is 4. Capital N is number of values that it has, so the length of x of n is 4. So your n minus 1 is going to be 3. Okay, so n will go from 0 to 3. You will substitute the values of n over here. You will get xk is equal to, put n is equal to 0. You get x0, and this is wn raised to 0. Then you put n is equal to 1. You get x1, wn raised to 1k. Put n is equal to 2. You get x2, wn raised to 2k. And then you get x3, wn raised to 3k. Now, x0, the value of x0 is the first value, or this is n equal to 0, so x0 is just 1. And wn raised to 0 is also 1. Anything raised to 0 is 1. So that value is also 1. Now, the value of x1, so when n is 1, the value of x1 is 2, and this is 3, and this is 4. So now let's write down xk again. Well, I've got xk is equal to 1 plus 2k, 2 wn raised to k plus 3 wn raised to 2k, 4 wn raised to 3k. Well, that's my xk. Now, once I got xk, all I have to do is I have to substitute various values of k to get the final answer. So first value I'll put is k is equal to 0. Now when I put k is equal to 0, notice that every w will become wn raised to 0, wn raised to 0 and wn raised to 0, which is just going to be 1. And k is 0, so I'll get xk as x0. I just put k as 0. And I get 1 plus 2 plus 3 plus 4 The answer is 10 if you add them all. That's the value for k is equal to 0. Now like that, after k is equal to 0, the next value I'll put is equal to k is equal to 1. Now when I put k is equal to 1, the xk will become x1. And x1 value will be 1 plus 2 wn raised to 1 plus 3 wn raised to 2 plus 4 wn raised to 3. Now we have to find out the values of wn raised to 1, 2, 3 and 4. 1, 2 and 3. So it goes like this. The real method of solving is raised to 1 is e raised to minus j 2 pi by capital N. You can call it j or I depending on, engineers usually want to call it j. But anyways, it's just iota. So now you have n is equal to 4 right now, right? Signal x of n is of length 4. So let's put n is equal to 4. So if I put n is equal to 4, this becomes e raised to minus j pi by 2, right? And e raised to minus j pi by 2 is cos pi by 2 plus I sin pi by 2. Now sin 90 is 1 and cos 90 is 0. So you get 0 plus 1i, which is just I. Okay, that's how I found my wn raised to 1. You can similarly find wn raised to 2 as well. But then there is a trick to that. Wn raised to 2 can be written as wn raised to 1 raised to 2. Okay, so this will be, wn raised to 1, the value is I. So this become I square is minus 1. Similarly, you can write wn raised to 3 as wn raised to 1 into wn raised to 2, which is wn raised to 1 value is I and wn raised to 2 is minus 1. So you get this as minus I. So we have all the values. We have wn raised to 1 is I. So this value is I and wn raised to 2 is minus 1. So this value is minus 1 and wn raised to 3 is minus I. So you get wn raised to 3 as well. And from putting all these values back in, you will get x1. You will get x1 is equal to 1 plus 2i minus 3 minus 4i. And now we can just add real with real and the imaginary parts with the imaginary numbers. So 1 minus 3 minus 2 and minus 2 minus 2i or 2j. That's whatever you want to call it. Anyway, so I got x1 and that was at k equal to 1. Similarly, now let's put k is equal to 2. So supposing if I put k is equal to 2 in the main equation of x of k, I'll get x of 2 is equal to, this is 1 plus 2. Now I'll put k is equal to here. This is wn raised to 2 plus 3 wn raised to 4 plus 4 wn raised to 6. Now there can be a shortcut way of solving the values of wn as well, and the shortcut way is like this, that you can just write this as, this is your real axis and this is the imaginary axis, and real values are 1 and minus 1, imaginary values are plus I and minus I. So your wn raised to 0 is 1 and then just go clockwise. Look, wn value is nothing but e raised to I theta. So it's just a polar form that I'm writing down. But you can just use it as a thumb rule that wn raised to 0 value is 1 and the next value is wn raised to 1. wn raised to 1 is I. Look, we've already got that. wn raised to 1 is I anyways. And then keep going that way. Then wn raised to 2 is minus 1 and wn raised to 3 is minus I. And then you can keep going. Then you get 4 and 5 and 6 and 7 and 8 and 9 and on and on and on. So you can now refer to this diagram and get all the values. You can completely eliminate, this is really not required to solve. You can just use this technique and get it. But anyways, we got this from here anyways. So, I have wn raised to 2 value. Where is wn raised to 2? wn raised to 2 is minus 1. So I'm going to use this now. And then I get that minus 1. wn raised to 4 would be 1. wn raised to 4 is 1. And wn raised to 6 is also minus 1. Alright, so I got x of 2. So the value of x2 is x2 is 1 minus 2 plus 3 into 1, that's just 3. W6 is minus 1, minus 4. So I get x2 is equal to minus 2 and minus 4 is minus 6 and plus 4. Is that minus 2? Yes, x2 is minus 2. Similarly, let me solve for k is equal to 3. Well, I'll put k is equal to 3 in here. So I get x3. x3 is equal to 1 plus 2 wn raised to 3 plus 3 wn raised to 6, because k is 3 now, right? So 2 3 is 6. And then last value will be 4 wn raised to 9. And then wn raised to 3, the value of wn raised to 3 is minus I, wn raised to 6 is minus 1, and wn raised to 9 is just plus I. So I or j, whatever you want to call it. Okay, so I get x of 3. If you solve this, it's going to be minus 2 minus 2j. Well, then I've got x1, sorry, I've got x0, 10. I've got x1 as minus 2 minus, so let me highlight them. X0 is 10. Then I have got x1 as minus 2 minus 2j, x2 as minus 2, and x3 is minus 2 minus 2i. And now let me write down the final answer. The final answer is going to be xk. The values are 10, minus 2, minus 2, minus 2j, minus 2, minus 2 plus 2j. And these are the values I've got at k equal to 0, k equal to 1, k equal to 2, and k equal to 3. And that's my final answer. And that xk here is the discrete Fourier transform of x of n, 1, 2, 3, 4. Now, as I said, there are various methods you can do the same question. Okay, so now let me show you the method 2. You can just like take the same method 2 as a shortcut method. Let me explain to you how this works. That for method 2, okay, we'll be using DFT matrix. Okay, so the discrete Fourier transform can be expressed in the form of matrix, and you can use that matrix to find out DFT of x of n. It goes like this, that your xk, okay, is equal to, you can write down the matrix. The matrix is like this. You write down 1, 1, 1, 1, and then write 1, 1, 1. Then this is minus j. Just remember the structure. You write down all the ones, and then minus j, diagonally opposite minus j, and then it is plus j and plus j, and then make a diamond of minus 1, like minus 1, minus 1, minus 1, minus 1, and put down 1 at the center. Now this is like the DFT matrix. How do we find the matrix? We will discuss that in some other video. As of now, this you can just remember as a discrete Fourier transforms matrix. Okay, and multiply this matrix with whatever x of n you have. You have x of n value as 1, 2, 3, 4. Then multiply these two row by column. Okay, so once you multiply these two, this is a 4 by 4 matrix. This is 4 by 1 matrix. It's a column matrix here. So when you multiply the two, you will get xk, and of course the xk value will be exactly same as this. So your values are going to be 10, minus 2 plus 2j, minus 2, minus 2, minus 2j. I think that's minus 2 plus 2j. Is that minus 2 plus 2j? wn raised to 1 is I. Okay, fair enough. Minus 2, minus 2j, and minus 2 plus 2j. Oh, that's all good, all correct. So I've got the method 2, and method 2 is by using DFT matrix. I got the answer. Okay, so that's the method. And let me just like tell you how the matrix works once again. You have to write down 1, 1, 1, 1, 1, 1, 1, 1, and then write down minus j first over here. This term I wrote first, and then diagonally opposite minus j over here, then plus j here, diagonally opposite plus j here, and then make a diamond of minus 1 like these 4, and then put 1 at the center. That's called as a DFT matrix. Now once you get a DFT matrix, just multiply your x of n. Now this is given x of n from there, and just multiply the two matrices and you will get the value of xk. Yes, a lot simpler. But this matrix is derived from the original formula of DFT anyways. So maybe if it is 1 mark question, you can probably use this as a shortcut method to find out the x of k of given x of n. Okay, so that's method 2. Now there is one more method to solve this question. Okay, now the next method here method 3, you can use FFT. You can use fast Fourier transform to solve the same question. Now FFT, the full form is fast Fourier transform, is again of two types. One is a decimation in time, we call it DIT, or the another one is decimation in frequency, which is DIF. So first let us discuss how DIT works. So decimation in time, it is the fast Fourier transform is nothing but a flow graph. So I'm just going to draw a flow graph and I'm going to tell you the rules and some guidelines to make sure that you always get your flow graph right. So it works like this. Okay, so first you have to draw 4 lines. Reason is your x of n has 4 points. Anyways, once you draw 4 lines, you have to draw small crosses like this. And then you draw bigger crosses, like connect first line with the third line and draw a parallel line again. Then connect first line with the third line and draw a parallel line one more time. Now this is pretty much the structure of your graph. Now you have to remember a few things, that for every cross, okay, you will have -1 at the base. So even this cross will have -1 at the base. Now if you see the bigger cross, it should have -1 at the base, and even this cross will have -1. So every cross will have -1 at the base, just remember that. And then this value is -I or -j. And this is the structure of the graph. Now the principle of discrete Fourier transform says that whenever you have xn, and if you take discrete Fourier transform or fast Fourier transform, you basically get x of k. Now x of n gets converted into x of k, and x of n is your time domain signal. That's TD, full form is time domain, and x of k is a frequency domain signal. So the k is a frequency and t is time, right? That's the basic idea of discrete Fourier transform anyways, okay? So, well, and when I want to do this decimation in time, the decimation simply means that we will take the alternate values. So now we will decimate here. So the decimation is over here, because this being time domain and this being frequency domain, we will decimate in time domain and not in frequency domain. So now what you will do is you will write x0, the first value of xn, and the first value is 1. And then don't write x1, write x2. So I'm taking alternate. I'm taking x0, x2, then x1 and x3. So you take 1, 3, 2, 4. Yeah. Oh, sorry. 1, 2, 3, 4. So it's alternate. 1, 2, 3, 4. Okay. So I've got all the values on this side. Now I'll tell you how the flow graph works. Now, whenever you have a flow graph, okay, the values are traveling from this side to this side. It's pretty simple. So what you do is you take this 1, and that 1 will reach here, and then this 3 will reach here. Okay, so this 1 and this 3 is going to get added up at this point, at this junction, and you get 4. And you have 1 coming from here, and 3 becomes -3. So you have 1 and -3. Now at this point, they will become -2. Do that here as well. So you have 2 and 4. 2 and 4 will add up to 6. And 2 and -4 will give you -2. Now you have to keep, flowing forward. So it gets, the 4 comes here and the 6 comes here and you get 10. Of course, the answer has to be same. And we are getting the first point, and first point is 10. So that validates the flow graph as well. Anyways, so now you have -2 coming here, and then -2 gets multiplied with -j. -2 into -j would be +2j, and that comes here, -2. Oh, the answer is minus. I was doubting that. But anyways, the answer is -2 plus 2j. There must be some mistake with plus minus. Why don't you check that and let me know? Anyways, so now I have got 4, but this is correct, okay? So this has to be plus, and this will also be plus, and then this will be minus, and this will be minus. Please fix it. It looks like some calculation error. But anyways, this is 4 and minus 6. The 6 this is for sure correct. 4 minus 6 gives me minus 2, and minus 2 and then minus 2 minus j will become plus 2j, and minus 1 is minus 2j, so I get minus 2 minus 2j. That's the next value. So I've got all these values here, okay, and that's my xk. So these are the values of xk, right? So there you go. That's like method number 3, okay, and that method is FFT by decimation in time. And now the last method we have is method 4. Now let me quickly give you method 4. You can guess it. Method 4 is again FFT, but this time if I have DIT, I can also have DIF. The full form of DIT was decimation in time, and the full form of DIF is going to be decimation in frequency. So now next time solving is decimation in frequency, we're going to draw the flow graph. So it's kind of a practice for you all as well. How do we draw a flow graph? Now FFT is fast Fourier transform, that is done using flow graph, and we want to do decimation in time. And we have our x of n, which is of length 4. So if you have length 4, you will draw 4 lines, like 1, 2, 3, and 4. 4 lines. Well, the graph of DIF is exact same, but the mirror image. So you just have to draw mirror image of DIT, and you get DIF. So you have to draw the small crosses on this side, and then you have to connect 1 and 3 here and draw parallel, and connect 1 and 3 here and draw parallel. And this is your graph. Your graph is ready. Now once you get your graph ready, all the rules remain same, that every base of the graph will get -1, like every cross will have -1 at the base. These cross will also have -1 at the base, and this cross will also have a -1 at the base. So once we write all of that, well, this is DIF, right? Decimation in frequency. So now these values have to be decimated, or we'll take alternate. Like we took time decimated, now we'll take frequency decimated. DIT and DIF. Now when I do DIF, I will write this x0, no, not x1, x2, right? Exactly, that's decimation. And x1 and x3, you can see even and odd separated. That has happened here because it was DIT, and now this is DIF. And DIT, this is not decimal in time. So x0, x1, x2, and x3 will go straight. I hope you understand the meaning of this arrow, that it's not decimated at all. That's what that arrow means. So I can just write down the numbers directly. So I can write 1, 2, 3, and 4. Now let me solve this graph like real quick. Just go from here, you reach 1 here, and get 3 over here. 1 plus 3 is 4. Then you have 2 and 4, which is 6. Then you have 1 and -3, which is -2. And you have 2 and -4, which is -2 again. I forgot -j though. The -j sits here, like exactly like, it's just a mirror image of the original graph. Well, then you have 4 and 6, that becomes 10. Then you have 4 and -6, that is -2. And -2 and -2 minus j would be +2j. So it's -2 plus 2j. And -2, this is 2j, -1 is -2 minus 2j. So you basically add wherever there is a, now this value will come here and this value will get added to that. And that's how I get these values. But look, these answers are not straight, they are decimated. So when they are decimated, you have to write down the final answer in a proper way. So now once again, if I have to write x of k, the answer, it's going to be, the first value is 10. Then not that, take x1, which is -2 plus 2j. Then take -2, then -2 minus 2j. And that's your final answer. So we have literally solved the same question in 4 different ways. The first method was using the legit formula of DFT. All good. It's a little lengthy, but then this is the real method. Anyways, Then from the formula we have derived a DFT matrix, and then we can just simply multiply the DFT matrix with the function, the signal xn given to us, and you can find out xk that way. Or you can use a discrete Fourier, or you can use fast Fourier transform. Fast Fourier transform is always in the form of a flow graph, and the flow graphs are of two types. One type is decimation in time, another type is decimation in frequency. When you have a decimation in time, you will decimate on the time side, the time domain. When you have decimation in frequency, you will decimate on the frequency side, which is this side, and no decimation here. And if you see that way, DIT and DIF are just the mirror image of each other. And these are the various ways you can find out discrete Fourier transform. Now, about how discrete Fourier transform is connected to other transforms, what is the mapping like, what are the significance, how it works, what are the applications of DFT, all that, very interesting, but we will keep that for some another video. So just check out the playlist, and if you have any doubts, or if you have anything that you want to ask me about DFT, if you want me to make a video of particular topic or chapter, okay, you just let me know in the comments, and thank you.